Well, thank you for joining me on exercise 2b. I'm going to be looking at question 2b. And question 2b says to use the information shown in each graph to write the equation of the quadratic function it represents. Select the most appropriate form for finding the function. Well, what have I got? I've got the two intercepts. I've got the intercepts at -3, 0 and at 1, 0. And I've got the y-intercept at 0, 3. So let's first of all write the fact that we know if we've got the intercepts, we could just simply use this method. And we've got to remember that sometimes our original parent function could be stretched. And so if it's stretched or if it's squashed down, it could still turn. So we've got to have some k for the stretch factor. Let's just remember that. So we've got x minus -3, and we've got x minus 1. So this is using the concept that x minus the two turning points, x minus a and x minus b. So we've got this situation where it's crossing at A, it's crossing at B, and let's have a look at this graph here. Y equals k, x plus 3, x minus 1. Now, if we substitute 0 for our y-intercept and get 3, find our k value. So our y value has got to be 3. Let's see if there is a stretch factor here. 0 plus 3, 0 minus 1. So we've got 3 equals 3 times -1, which is -3. Well, if k times -3 equals 3, therefore k equals -1. And that makes sense because we've got this concave down curve, and that means a has to be negative. And so our final result is, therefore the equation is y equals -1, x plus 3, x minus 1. Now if you expand that, it looks like this. Negative x squared minus x plus 2x minus 2x minus 3 plus 3. And so there is the equation written out. Shows that it's crossing the y-axis at 3, it's concave down, and it'll turn at it turns on the left hand side of the axis. Yes. I hope this has helped. Until next time, stay happy.